kind of give you some idea, like a visual way to look at that equation, like delta y equals m lambda over d. So what I have here are two speakers, okay? So if I turn these on, it's going to emit some sound. So if you look at what's happening, that's very annoying sound. So this is like basically like a double slit experiment. These just have to be sources of some type of wave, okay? So in this situation, I'm producing a sound wave. So the distance between these two would be like the distance between the double slit experiment, like how far apart they are. So as these waves are going out, and again, we represent them as transverse waves. In reality, they're longitudinal waves. This is the transverse waves. So these are coming out, okay? So this distance here between those two is the value of the sources. That's that value little d. They're going to have a certain wavelength out here. So as they come out here, the distance, and what you're going to do is you're going to walk across here. So this distance here between these two, that's that value of L. So how far apart you are. So what's going to happen is I'm going to have you step over here, okay? And then you're going to walk across like this. Okay, so you'll be traveling across. And some people hear this a little bit easier. Now, you will never hear it go like completely silent. Like it will never cancel each other completely out. But if you listen very carefully, as you go across here, if you walk very slowly, you can hear points where that gets a little bit, where you'll hear it noticeably get louder. And then you'll have points where it gets quiet. So this point right here, okay, this would be that central maximum. This is where those wavelengths are interacting most. So this would be this first one. This would be the central maximum. So then where m equals 1 would be like this first one over here. So that would have to be a multiple of the wavelength of that sound. So it's actually longitudinal, but we view it as transverse. So you have these waves coming out like this. It's sound. It's a pretty long wavelength. So as that's coming across like this, they're going to reach a point where a multiple of those wavelengths, they're going to reinforce each other. And it's going to get loud. Okay? And then when you move a little bit further over, you'll hear that noticeably get more quiet. Because that's when you're meeting like trough to crest. I tried to combine the two words together and I got trough. So crest to trough, they're going to cancel each other out. It's going to be a little bit quieter. Now, I don't want you to think like, oh, you do this and you'll hear it really, really loud, and then it's going to go completely quiet, and then it's going to get really, really loud as it goes. No, you're still going to hear these sounds, but you should be able to hear it noticeably get louder and then get a little bit softer. Okay? Because you might not be able to hear this because of the damage you've done to your hearing because of where it is in your phone. But I'm just saying. So here's what I'm going to turn these on. Okay? And it's got to be very quiet because that's the only way you can hear this. And some people hear this better than others. So you're just going to start over here and you're just going to walk very slowly. Some people it works better if they just listen in one ear. Some people it works better if they turn like this where they can hear both of them. But what you should hear is that you hear this get a little bit louder, then you go a little bit further, it's going to get a little bit quieter, get a little bit louder. So this is just an auditory way to show what happens with a double slit experiment. Okay? All right, so I'm stop the camera and